Thank you, Joseph, for that introduction, and thank you for RCM for giving me this opportunity to share my faith in my profession. And as surely I'm going to be talking about software development. Um, this presentation is split into two parts. At the first part, I will be talking about uh, well, the field I work in, of what software development is and what it isn't, and I'll the second part will be how I view my work and my profession through the lens of my faith. And so let's dive right in. Again, I'm John. I'm a software developer. I've been doing this for 11 years now, and like I said, I am a lead software engineer for PageUp. Uh, I couldn't find a better picture of me actually doing my thing. So I have this photo from years back. Um, but yeah, you know, we some summarily what a software developer does is in the name itself. We develop, we build, we make software. Nothing that I have to explain to most of you. You are probably connected through Facebook or Zoom, and in that means you're using software. It's uh, a pervasive tool that has been a part of our daily life, and we are in our generation, particularly in this pandemic, it has been very helpful in connecting us with each other, even though while we're quarantined, and it's a key part of our life. And my job in the profession and my profession is to be part of that workforce that makes software. Um, a little note on like the different titles you've probably heard: coder, programmer, software developer, software engineer. Um, I'll I won't go into the detail or the debates on like what I should call myself. Uh, for the duration of this talk, I'll just be using some of these interchangeably. I'll primarily be referring to myself as a software developer. Um, if I had to give a quick qualification, coder programmer is what I'd call myself when I do the act of programming and writing code. And uh, I feel like the last two, software developer and software engineer, kind of encompass a person when they are engaged in the act of developing software as a whole, the whole cycle, which I'll get into in a bit. One thing I'm not though is that I'm not a computer scientist, and I did initially decline the invitation to give this talk because I don't practice the science part of computers. Um, Computer science deals more with the theoretical, the algorithms, like what are the mathematical equations involved, or the algorithms, designing new algorithms, and start spending years in research uh, and study in order to delve into those details. I'm not one for academics. I would much rather get my hands there and prove whether something is feasible by building it. And I did not uh, I did not find myself suited to practicing computer science. So I would say that software development is more like applied computer science, and that's where I probably where my profession fits in. Um, just a funny side note. Uh, a lot of people go into computer science and IT thinking like I had a lot of batchmates na said na kaya ako nandito kasi ayaw ko ng math. Lumipat ako galing engineering. Uh, which to their dismay is like uh, there's a lot of math in computer science. So if you're considering a course in college or you're considering shifting because you don't like math, IT, uh, computer science are not the courses for you. So anyway, uh, so there's a lot of fields in software. There's a lot of kinds of software, and I want to talk about like my specific field where the subset of software development that I work on. I work on business software solutions. which is funny how I found myself here because I took up computer science because I said I was good at I like playing computer games. Therefore, I will take up a career in computers and study computer science, which is like saying I like living in houses. Therefore, I will take up civil engineering. Uh, yeah, and well, anyway, I found myself working on business software solutions. Like I said, let's d- dig into this a little. And so, what I mean when I say business, we have what we call B2B. So, likely unless you're working and your business has purchased software that the company I work for has made, then you would probably not have encountered anything I've worked on, because the my business sells to other businesses, and we build software that's tailored for big businesses and organizations like HR software, which is where what I do when I'm employed. Uh, we've got accounting, ERP, manufacturing software. So like it's not something an individual would buy off the shelf, as opposed to say B2C, and that's what you usually encounter. Like Zoom is business to consumer software. Uh, Facebook, uh, YouTube, Airbnb, and those would be like when you say software, that's probably what you think of. Yeah, I don't work in that space as I haven't worked in that space in my career. So yeah, I work on business software solutions and a little jargony, mostly when it comes to sales. Yeah, we say software solutions. We sell software solutions, and it's called solutions because people have problems. People have lots of problems, and we come up with solutions to those problems. And sometimes the solution is has or involves some software, and that's why I say like yeah, we I work on business software solutions. So talking about solving problems, how do you solve a problem with software? And my role there is kind of like building the thing. uh, we build software and I'll make a profit from it from our hard work. Is it really that simple? Do you just write the thing? This seems to be, I mean, from an outsider, of course, like uh, there's this common joke, kind of like joke we have. It's like there are people who usually come like, I have a great idea. Um, I heard you were a computer science graduate. Can you build me this? We'll make lots and lots of money. And kind of an oversimplification of like the whole software development process. And I'll talk a bit about that in this next section. And sometimes software is easy to build. This is a simple to-do list pulled out from a tutorial. There's hundreds of them out there. Uh, that features are very simple. You've got uh, enter the task for your task list, and then you can delete tasks in your task list. And something like this, like I have fair confidence in my skills that I can build this over a weekend probably, uh, and then have that usable by other people. But software easily can easily grow very complex. This is another to-do list. This is from Todoist, the Todoist app, and what a simple to-do list can easily grow into something that's largely complex. Like you see here, there are features like upcoming, uh, today, so like tasks that are time sensitive, projects, and categorization, and there's probably account management. So that kind of software, I probably wouldn't be able to build by myself in a reasonable amount of time. And then that's the time that you kind of start pulling in other developers to work with you. And then now you need other developers, you need researchers, you need analysts, you need designers, you need managers to coordinate all of that. And so the problem solving process becomes more than just building the thing. You need to do some planning, researching, designing, and then that's only then you build according to the design. So I want to talk about these last two steps in particular. Project management research for another. It's another place that well I do some of that. That's not. I mean, you're here for software development. Let's talk about uh, the parts where we're in execution. So designing a solution, building according to the design, and uh, hopefully to help people understand like what happens when you build software and these two steps in particular. I'll use an analogy from construction. Um, construction, when we design a solution, I imagine civil engineers of the group, please correct me, that civil engineers and architects come up together to work on these blueprints, sketches of the structure that you're about to build. When you're done creating those designs and documenting those designs and those artifacts, you pass it on to construction workers who build according to the design. And like most of those other industries, the process is largely the same way. You come up with these documents of like what the thing is supposed to do, how we're going to do it, what features should be part of that product. We have these schematics of like how we're going to organize our code, our systems, how do we deploy them. And then we imagine that at the end of that design process, the documents have been laid out. You hand them to a bunch of programmers to translate that into code. So that translated code can be given to a machine. And so we imagine that the problem solving process, the process of creating software, much follows the same way. There's a group of designers to the left of this diagram, and then they get hand that those designs that they output get handed over to programmers so that they can build them. And yeah, that's the part where we start writing code. But there is one thing I want to kind of get correct with this model. I'm a believer, and I'm I'm a believer that we don't just the programmers aren't actually the parts. I mean, writing the code, writing this code that you see here, isn't actually the part that the isn't actually the build step. That's still part of design. Programmers still do design. And you might ask me, like, okay, if you're doing design, then there's obviously still a build step before you collate those designs and it becomes software. And yeah, there is. We've got a computer. The computer does that. Um, how it does it? Well, um, yeah, uh, the code you write, the code comes in the form of a programming language. That language has two functions. One of its function is as instructions to a machine. So, uh, so one of its functions is as instructions to a machine. You tell the machine what to do. This is when we think of writing code or we think of software development. This is kind of like what most of our mental models are. That the code we hire a bunch of programmers to write the code and translate into something that's machine readable. But it serves actually another function, and that's communicating your design to other people working with you. We said earlier that any a sufficiently complex program might uh, we need to have more than one person working on it, and so code communicates that design to other people as well. There's also the fact that if you don't design your code well, if your code does not communicate the design, then there's a disconnect between it and reality because your code is not structured the same way that the reality of your solution is structured. Is structured. So, um, how? Okay, I hope I don't lose you here. I'm going to show you what in what way, in this example code, uh, you this code functions as a way to communicate with other developers, how it communicates design. So I have here code for a shopping cart application. The way I would read this is that, okay, we have the concept of an item. When an item is constructed, it needs to have a code, an SKU, in SKU probably in inventory parlance. And that item would also have a price. And those items can be added to a cart. When you add an item, you need to specify how many of that item gets added to a cart. So you see here, this code is not meant only for machines. It's meant also for people. And this is the final, most authoritative form of design. Uh, you so again going back, I hope that painted a picture that writing code, programming is uh, not just an exercise of translating it for the machine. It is also a design activity. We try to design our solutions to problems, and it's an exercise of coming up with a model of a solution that gets translated, where portions of that model gets translated into working software that people can interact with. So I want to touch briefly about this whole the computer actually does building, and uh, and in order to kind of help you kind of illustrate that view, imagine going back to our construction analogy. Imagine that if you gave there's a machine that if you gave it a floor plan, that machine can build that floor plan, that building based on that architecture in a matter of minutes to hours to days. That's what computers do for us. Computers translate our designs in a relatively short amount of time. Software is very cheap to build, and that's an advantage of our industry, of the software development industry. If you go through the Google Play Store, you go through the Google Play Store, there's I pulled the statistic out, the first result from Google. There's 2.56 million different apps available just in the Google Play Store. And that's not counting the App Store. That's not counting the millions of websites in the internet. That's not counting applications you install and comes with your Windows machine or your Mac or whatever device you have. Software is very cheap to build, and we're in one of the rare we have a rare opportunity that we don't have to spend all that time building and waiting months to see the output of our hard work, of our ideas, to see whether something makes sense. We spend most of our time as developers doing design. That has allowed us to expand the boundaries of the problems that we can now solve. That you hear this word innovation with, tied to the software industries, to the software industry, because, like I said, because building software is cheap, then we can build a lot of things. We can experiment. It opens up a lot of doors. Facebook was famous in the early 2000s for their motto of move fast and break things, and that's one way that they were able to get ahead of their competitors. That rather than spend time designing the perfect product, uh, they would release features. They would make changes. That's why you get every few months like, oh, my timeline moved and Facebook changed something again. Uh, that's rather than wait and make plan for and design for the perfect product. We can keep designing and then building as we learn from our ideas, as we learn from our product. The build process is very cheap. This has helped us solve more problems, more important problems, more complex problems. And that's something, an advantage that software has over other industries. I want to talk about complexity a little more. I want to talk about information systems in particular. You might have heard about this. Uh, so, software, particularly software in the business space, but not limited to our field. Software exists as part of a system, much as everything in the world does. It's not built in isolation. So, and this is the part where I say, like, okay, as a programmer, I can write a program and create an individual piece of software, but that software exists in a system. And as a software developer, a software engineer, I have to look into the bigger picture. What's an information system? Uh, from this definition and Encyclopedia Britannica, uh, set of components for collecting, storing, and processing data. So we say like data is unprocessed, and the data until it becomes processed does not become information. So in the business space in particular, like yeah, information is valuable, and this software, much of mm, a lot of software exists for the purpose of like processing, collecting, managing this information, and making it useful for our day to day. Take your enrollment system, for instance. We collect information about the students as they register in the system, and then that system is used to track grades. Maybe you store information about the student's permanent record, and you can imagine maybe as students, maybe as people who have interacted with such systems, you can imagine that you may have interacted with not just one system, or maybe it's the same system, but there are different components and different software interfaces that you interact with in order to uh, get information in and out of this system. Same applies to consumer software like social media. As a user of social media, you are part of the system. You contribute the information that's used in social media, and we've heard that also that social media uses your information and sells it to other people, and that's also part of the system that that software is part of. So my point here is, I hope that shows that yeah, software does not exist in isolation. When we solve problems, or when a software developer solves problems, they should not only look at the software that they're building as an independent component, but they should look at the bigger picture. They should look at like who are the people that interact with this. What are the systems uh, in the big picture that depend on the information that comes out of the system? How does this affect the lives of the people that will be interacting with this? Yeah, that's software development in a nutshell, and I hope that paints a picture of like what I do. Write code, and when I write code, it's usually to build software or ask the computer to build software for me. And that software exists not in isolation, but as part of a system. So part of my profession is also to consider the context, consider the environment that and the system, the overall system that this software exists in. And with that, I'll go to the second part of this talk and like how do I view software development? How do I view my profession and through the lens of my faith? And um, there's an excellent talk by Brother Jonathan Lasco a few weeks ago on the same series. The video is available on YouTube. If you'd like, I would recommend that you look into it as well. And the reason why I highlight this is because I feel like he covered a lot. I'm very grateful that my talk came in after this, after his talk. Well, I mean, it was supposed to come before, but because I got sick and we had to move it after this talk. But I think that played out well because I do view why we call ourselves software engineers sometimes is because I feel like we're closer to engineering than we are to sciences, to the engineering part of these disciplines, not less towards the science side of it. And much of the applications that he drew and his reflections are applied to software development as well. I don't want to duplicate what he has been talked about and uh, or better discussed in forums for about engineering. But I may mention some of this here as I reflect on on my own on software development and my faith. Another thing I want to mention is how my vocation. I really appreciate the theology of vocation that we've been taught in the church. It has guided me. It has been a guide and helped me get through a lot of the challenges in the workplace. And I won't be talking about that there, but it's I think it's worth referencing in terms of like what challenges are there in the software development space and as a software developer. And I would say that yeah, um, it shares some of the challenges and reflections in engineering and faith, and also uh, much of the applications of like a proper understanding of vocation and calling also apply here in this space. So with that said, let me go over three or four things. And now I'm going to take a different tone here because like I said, some of this has been discussed already in those venues, like in engineering. I want to talk about what I love about working and that why my love for software development is guided by my belief and founded on my belief. Uh, and I have four points, I think. So let's get into it. And because I uh, fresh out of that discussion about information systems, I want to start off with this. I have working in software development has given me a greater appreciation of the complexity of the world. Because if you're trying to design software that exists as part of a larger system and tries and where you write code that tries to model the problem as it exists in the real world, then you will find out soon enough how very complex a lot of the problems that the world has is. Um, there's this quote from Russell Acuff. We have come to realize that no problem ever exists in complete isolation. Every problem interacts with other problems and is therefore a part of a set of interrelated problems, a system of problems I choose to call such a system a mess. Solutions to most problems produce even other problems, a financial problem, a maintenance problem, and conflict among family members, even for its use. And I probably don't need to draw a lot of examples, but think social media, for example, and that as much as it has connected us to each other, it produces some problems of its own. Like, yeah, like mentioned here, conflict among family members sometimes. And so working in this space has given me a greater appreciation for complexity of problems, a greater respect to the problems that we try to solve as human beings and try to solve in software in particular. And that points me to an amazement how everything just holds together and how not only are the systems in themselves complex as it is, as we'll probably learn throughout the series, biological systems are complex. And because information systems usually deal with behavior and interactions between people, you see like systems between people are complex. It just points me in amazement at just how the Lord has just holds all these things together. And like you even take into account the complex additional infinite complexity that sin brings these uh into these problems. We have an entire field of security that exists for the purpose of addressing addressing malicious intent uh, by malicious actors in the software development space. And yet, even with all that, we have we still see the goodness of the Lord's hand in our day-to-day life. We see these beautiful things brought about by software that advances in technology that we can greatly appreciate. Even this comes from the Lord, and yeah, working in software has made given me a greater appreciation for the immense complexity involved in the systems of the world. The second thing I'd like to talk about is the sheer joy of making things. And for this and the next point, I'll be pulling some quotes from this book by Frederick Brooks Jr. This is a classic a classic literature on software engineering written in 1975, and much of it still applies today. Um, I'm a side note. This okay. Yeah. A side note. The title of the book is "The Mythical Man Month," uh, wherein he talks about where people think that adding more people to a late project will solve those problems, and the Mythical Man Month says that uh, adding more doctors will not make the baby come out sooner. So yeah, it's a bunch of essays on software engineering as a whole, addressing problems on how to build software. But these reflections on faith, I was surprised when I first encountered this book. Uh, the first chapter, he talks about draw why he enjoys software engineering from the lens of a Christian, and I share a lot of his joy. And one of his first points, like he said, is this joy of making things as a programmer. So he says here, the programmer, like the poet, works only slightly removed from pure thought stuff. He builds castles in the air from air creating by exertion of the imagination. Yet the program construct, unlike the poet's words, is real in the sense that it moves and works, producing visible outputs separate from the construct itself. And so, yeah, like I said, because software is so cheap to build, we can just build and build, and there is this joy in being able to make things at a short amount of time, to be able to express an idea in code and see the output of that idea materialize in a matter of seconds to minutes. There's a joy in that to continue quoting him as the child delights in his mud pie. So the adult enjoys building things, especially things of his own design. I think this delight must be an image of God's delight in making things, a delight showed in the distinctness and newness of each leaf and each snowflake, which I fully appreciate as yeah, we are made in God's image, and we have been given dominion over the earth as and given these opportunities to share in the experience of creation in this small aspect. uh, there's a thrill to that. And we do know that the skill in order to be able to make these things is also comes from the Lord, quoted here in Exodus as God gives instruction to the craftsmen in that will be building the tabernacle. He gave them the we. It shows us that ability, intelligence, knowledge, and craftsmanship, all of this comes from the Lord, and they are given to make in this particular case to make according to the Lord's command to make these constructs as the Lord commands. So the ability to create the even the means to I see the technological advancement that now we have these machines that can convert our ideas into something material in matters unheard of in previous generations. This too comes from the Lord, and the ability to work there and experience this thrill of being able to build is a gift from the Lord, and a gift that certainly comes from Him. And so my last reflection is that well, there is the thrill of making things, but there's also the pleasure of making things that are useful to other people. And I think this is part also of our relationships, of our human nature. To quote again Fred Brooks, as he makes this point, deep within, we want others to use our work and to find it helpful. In this respect, the programming system is not essentially different from the child's first clay pencil holder for daddy's office. With that childlike fascination, uh, this we build uh, we build for much of what we build is not only just for the joy of learning or the joy of building in and of itself, but finding use in the things that we build. And it is and yeah, that's part of this. What when we build like this, it's not just that there's the thrill of building. Here in First Peter, we see in this passage that yeah, the things we build is used in service of one another, and uh, again, that comes from the strength that God supplies. But the but the much of what we build is what much of what we build is much of software exists to serve other people, and that has helped influence me uh, in guiding in guiding what I do in work, and also as a motivation for why I'm doing what I do. Uh, a quick story here, and usually you ask students, right? Where do you see yourself in 5 years, or like what are your goals and objectives in life? And like as a college student, mine was very naive and simple. It was I wanted to be independent. I wanted to be able to earn an income, and it seemed like software development was a lucrative job, and it's in my comfort zone. But one of my titas would always remind me, and that really stuck. That my goal should be to work, and we work to serve other people, and that is a profoundly Christian belief, and and that's always been a reminder. I I gave that answer in my first interview in my first job when they asked like, "Why do you want to work?" um, I want to serve other people and make software that improves on other people's lives. Uh, Sabi nga, baka noong panahon na yun ay labas sa ilong and hindi pa and it's more something an idea that was instilled in me, but I was half-hearted. I would honestly say that I was that was not something probably I wholeheartedly said at the time. But even in the Lord's providence, I think he did not grant me my desire to work in a game development company. He put me in a place where the software I built uh, was to help others and improve others' lives. And uh, I mean, not to say that building games does not improve other lives, but I think for myself, this had a more direct, I think, a more direct impact, and like I think in every step of my career, that's where I usually found myself. Uh, and the Lord leading me into greater responsibilities, greater scopes of responsibility, and greater scopes of responsibility that tried to help uh, help and serve other people in the things that I was working on. And so, with that final note, something I always keep in mind is that technology is from the Lord. I think software development, software engineering is at the forefront of these technology advancements because of the aforementioned things are cheap to build. Uh, it's not like a rocket that we're trying to send into Mars that it really needs a lot of time and building takes months to years. Uh, an idea uh, this has pushed the boundaries of innovation in our generation. Uh, and whether you're on the consumer side of this technology or on the side of the builders, it pays to uh, look at this with look at this from the perspective as this technology comes from the Lord, and this technology is meant first and foremost to be used in service of Him and to proclaim the glory of our perfect Lord who has allowed us afforded us these technological advancements. And yes, it should be also used in service of other people. And with that, that concludes my talk. Thank you for joining. And I hope you learned something, and I hope that was helpful to everyone.